So for example, if you're reacting this alkene with HX, we know that this reaction follows Markovnikov addition, so that means hydrogen adds to the carbon with the most hydrogen, while the X adds to the carbon with the least hydrogen. Now the mechanism has two steps. So step number 1 results in the formation of a carbocation. Step number 2 involves a nucleophilic attack on the formed carbocation. So let's go ahead and write the mechanism for this reaction. So we start with the alkene and then react that with HX. So what's going to happen is that so we're going to show the HX bond, and then the alkene is actually has a higher electron density, so it becomes a nucleophile. So the alkene attacks the proton, that's the hydrogen that's connected to the X, and at the same time the HX bond electrons flow to X, so that bond breaks and that flows to X to become an X minus. The result for that is going to be, again, you draw the backbone of the alkene but now without the double bond, and then the H adds to the carbon with the most hydrogen, while the other carbon becomes a carbocation, and we put a positive charge on the other carbon. At the same time, the electrons flow to X, and therefore you have a minus charge on X. This will proceed through step 2, where now the nucleophile, that's the X minus, will add or attack the carbocation intermediate, resulting in the formation of this product, where now the X is attached to carbon with the least hydrogen. Now looking at this reaction in this step number 1, there are two possibilities. You could actually end up with the hydrogen adding to this carbon instead of the other one and end up with a carbocation on that position. The problem with this is that now this carbocation is a primary carbocation, and that's because that carbon is connected to only one other carbon. On the other hand, the carbocation that we form here is actually a secondary carbocation, and that's because you have 1 and 2 carbons connected to that carbocation. So you have 2 alkyl groups, and we know that secondary carbocation is more stable than primary carbocation. In fact, primary carbocation almost never forms because it's highly unstable. The stability of carbocation is tertiary, more stable than secondary, which is much more stable than primary. And of course, that's more stable than methyl carbocation, so CH3+, because that one doesn't have any alkyl. This explains why the Markovnikov product is favored, because this gives the Markovnikov product, while this other one will give the anti-Markovnikov product, because you end up with the halogen attacking that carbocation. So you end up with the major product being the Markovnikov product, and the minor product, that becomes the minor product, anti-Markovnikov product. The major product is the Markovnikov product.